I still see some more additions, but I think they're slowing, so maybe we can go ahead and get started. Welcome everyone to the real-time internet peering for telephony, BOF, for IETF 107. Just a few quick administrative things. This session is being recorded. Please join the Jabber room for all chat and save the WebEx chat only for putting yourself into the mic queue, plus Q to join or minus Q to cancel that. Please go into the Etherpad and add your name and affiliation in the virtual blue sheet at the bottom of the Etherpad under the notes. And the note well, you should familiarize yourself with that, covering all IP declarations. And this is a birds of a feather session. So the purpose of this meeting is not to design, but rather to answer some key questions about whether or not there is a problem here that's worth solving, and whether the problem can be solved and should be solved here. And specifically, are there people that are willing to do all the work to solve it? And for those that are struggling to find the blue sheets, the agenda links have links to the Etherpad. So if you just follow the agenda links, you'll be able to sign into the blue sheets there. So our agenda today, we have Jonathan leading a discussion about the problem statement and proposed high-level protocol summary. Justin will give us some experiences with implementing RTC systems at Google and some of the pain points there. Anthony will discuss the signal wire free switch use cases and needs. Suhas is going to give us an overview of an experimental code base that's helped to prototype the proposed protocols. And then finally, Cullen will lead our charter review and discussion, and will answer the BOF questions we just presented. So Jonathan, you're up.
All righty, can folks hear me okay?
Very nicely.
All righty, outstanding. So thanks everyone, and appreciate everyone taking the time today, especially in the current environment, really. So we're going to talk about some fun stuff. So Mo, are you going to share the slides from your laptop?
Yes, they're.
All right, it's loading. Something. All righty. Okay, great. All right. So let me start off by talking about the problem statement that we're trying to solve here. Next slide, please, Mo. So I don't know how many of you have tried here in this audience to deploy voice over IP, SIP, and RTP apps in public cloud environments, but it is really, really, really a big pain. And sort of today, in the voice over IP world, we're stuck on the left. So if we want to deploy a proxy or a conferencing application or an IP PBX, you sort of have to go right to a virtual machine in these public cloud environments. And then because you're really using very little of what the cloud provider is offering you, and I mean by cloud provider, I mean like an Amazon or a Google or a Microsoft Azure, you sort of have to build a whole bunch of the classic layers yourself. So you have to do load balancing. So how do you do load balancing? Well, you know, SIP DNS load balancing sort of works, sort of not, you know, so people put some kind of proxy farms and you have to deploy those, and then you have to make them public facing, do your own whole network configuration, separate inside and outside, and then you probably want some SBCs for security, or you know, maybe put those in front of the proxies, as sometimes people do, sometimes they're on the other side. You have to sort of configure all the IP addressing and DNS stuff. You have to configure all the firewall on your own. And then actually a lot of the hard part comes from how do you make these systems highly available? Highly available voice over IP software today is really hard to do, right? And we all know that. For example, if you wanted to deploy SBCs, for example, in a highly available configuration, most people do it by like virtual IP address sharing, which, by the way, often doesn't work in these cloud environments with virtual machines. So in general, there's just a ton of work you have to do to get a bunch of capabilities that in the web world today, in the HTTP world, are sort of quote unquote for free, right? Meaning if you wanted to design a web application, you would probably do something like a cloud function, or you'd write a Kubernetes Docker container, and you take advantage of all this other stuff that these cloud platforms are providing for you today that make it really easy. There'll be a virtual machine on the bottom, but you'll get to take advantage of these pretty powerful global elastic load balancing tools that each of these vendors now offer. So Google and Amazon, and I'm most familiar with the Google stuff. This is just amazing, globally available, worldwide distributed, effectively infinite scale near as far I can tell, like HTTP load balancer that does TLS termination and routes to your backend instances and takes care of all the public IP facing stuff. And it's easy to make it work with their GeoDNS stuff, so you get right into the right data center. You literally don't need to think about any of this. Like, it's going to just work. And then you have an additional layer of tools like a Kubernetes that sits on top of it that you can deploy that makes it really easy to do things like, add and remove capacity and direct load, and a newer set of technologies. And I'll share a couple slides for this thing called Service Mesh that's really awesome, that does a lot of monitoring and troubleshooting. And so there's this growing stack of software in blue here that are the capabilities that are provided by these public cloud platforms that are really not possible to take advantage of today by real-time voice over IP systems. And so that's a problem, right? And then, by the way, there's a bunch of stuff on the left that's like hard, if not impossible. So elastic peering is, one of the ones that's been high on my list, which is, well, if you're doing something like SIP trunking or enterprise voice over IP SIP trunking, and you want to add or remove capacity from your side elastically on demand, today that's like super hard because there's no easy way to do add capacity without effectively giving a set of IP addresses to your upstream provider, because the DNS solutions for load balancing for SIP are just not good enough anymore for Elastic. They don't allow you to propagate changes fast enough or really detect downstream failures, and a lot of that was never standardized. It's all like this huge heartache, and so a lot of people end up doing, peer using IP addresses and do virtual IPs for HA, and you scale vertically, not horizontally. And this is really terrible. And it was fine back in the old days, but that's not how any of this works. So there's this growing gap. Hitless upgrades is another thing too, right? The whole web world has gone towards this fully stateless models as much as you can, where you can literally just upgrade a component, and you in the middle of a transaction maybe will have to be retried, but you're not losing anything. There's no, you didn't lose your shopping cart, or you didn't lose your purchase, or whatever you were doing on the web. And so on voice over IP stuff, SIP and RTP stuff, we never really got there. People use a variety of techniques, reinvites and refers, to try and move calls around, and they never were well standardized and almost never work on sort of cross-organizational links. So you have to wait for calls to drain, and sometimes you end up dropping really long calls, and you can't get the kind of availability that you get from modern web applications. So that's the big problem. Let's go to the next slide. I'll probably take more time here than a minute. So just to give some examples, like this is a product Google just came out with called Antho Service Mesh. So this is a nice, beautiful dashboard of your uptime and error rates. Next slide. And you get these beautiful dashboards. Next slide, Mo. Sorry, I just whizzed right back down. You get these beautiful graphs automatically generated of how your traffic is flowing between components. It will all just work if you have a web app. You have SIP. Oh, sorry, I forget. Next slide. So what is it about SIP RTP that makes this impossible? Mostly it's not a web app. It's not using HTTP, but there's other issues. It's not just that. It's that we have IP addresses all over the place, and that breaks a lot of how these platforms work, which are using higher layer constructs like URIs to do addressing. And then RTP in the cloud is particularly problematic, right? And again, it's heavy use of IP addresses and ports for session identifiers. It's actually usage of dynamic port ranges, in fact, incompatible with the way you deploy Kubernetes. Good luck with that. And SIP trunking, as I mentioned a few times, generally requires VIPs, virtual IP addresses, for any kind of that just does not work well in public cloud. So that's these are all the problems that we bumped into with this stuff. So next slide. So the problem statement is we want to allow voice over IP to take advantage of the new technologies that are available now in these public cloud platforms to do things like load balancing, HA, headless upgrade, service meshes, geo redundancy, and do that by minimizing, if not eliminating, the need for something customer unique to voice over IP. You can build, and obviously there's state in the voice over IP system, especially ones that have media in the cloud, which is largely what we're talking about here. But you can use the web techniques to do that. So next slide. So what I'm going to do, actually, so I'm going to skip this one. I'm sensitive to time. When we look at use cases that we want to solve for, those are the columns here in this graph, and there's a bunch of different use cases that we would think about this new protocol getting used for. One of them is sort of a browser to a cloud app. This is the area to some degree WebRTC covers today, but even with WebRTC, it's super hard to make the RTP piece of this work because, again, of these challenges in getting real-time voice and video in public cloud infrastructure. And I know Justin's going to speak more about his experiences with that in a moment. Another use case is an IP soft phone or hard phone to an IP PBX. And so for another use case that I'm seeing is app-to-app communication. We're starting to see more interest in streaming real-time voice between applications in the cloud. For example, many like Google and Microsoft and Amazon all offer speech recognition services that run in real time. And right now, today, you get them with gRPC, which is a web protocol that runs over TCP these days, and HTTP, of course, and suffers latency penalties as a result. Real-time devices like cameras, that has some discussion on the list, and then even doing things like SIP trunking, so connecting to the telephone network between an enterprise or a telephony UCAS or CCAS provider or whatever to get off to the PSTN through a carrier. Today, you do a lot of SIP trunking. That stuff is difficult to do in public cloud, and so it'd be great to have a better way to do that. So if we think about what are the capabilities that we need to do or to provide in this new protocol to solve that, if you look at the Ript draft at all, it's sort of broken into these four pieces: media transport, control, media negotiation, and identity management. And so that's what's in the current Ript doc that myself and Colin and others put together. And this matrix here sort of helps you understand which pieces of those protocols are needed for, these various use cases. So the best way to understand them is I'm going to take the last few minutes here and focus on an example of how the protocol works that we've written a draft of. So I'll start with the, rather than sort of time order of how a call flow would work, I'll start with the simplest part and expand beyond there. So if you want to shuffle media around, how does it work? So the way it works in this protocol is it's a web app, just runs on top of HTTP. So there's a web client and a server that wants to send media and get media. In the current draft, the way it works is the client has a call URI for the call. It's an HTTP URI. And it does an HTTP get operation using that call URI /media. And what it does is it actually creates multiple parallel GET requests. It does that largely to take advantage of the way HTTP 3 works with its usage of QUIC. And I'm not going to get into the details here, but it opens a bunch of these. This is an area where we're going to have lots of technical debate, by the way. Amongst the authors, we argued vehemently on this approach, but generally we're doing, in this case, a bunch of gets to get media packets from the server. When the server has a media packet to send, it generates a response to one of those gets. That's the final 200 OK that has a media chunk. And if the client wants to send media to the server, it does a put to the call URI /media with that media chunk in the body. And that's basically how it works. These media chunks are the same stuff that would otherwise appear in RTP packets, but we're using an HTTP encapsulation here to provide URIs as identifiers and other things that work better in the web world. So that's that one there. So of course, thanks Mo, next slide. So if we want to actually send media, we probably have to set it up. So the way the current Ript drop works is you create a call. The client creates a call object by posting to the server to create a call, and it gets back a call URI. That's the one it would use in the media exchange. And then to signal, so to do things like proceeding and alerting and answered and decline and all the things that we're all familiar with here, the client establishes a bidirectional event stream using a similar trick here. This time it's doing a classic long poll with a get to get a long running set of events that returns streaming JSON, and a put with streaming JSON on the request. Those contain events. Each of those events are these events you see on the right. Part of what's uploaded here is this thing called a handler. That handler is declaring media capabilities. How did that handler show up? That's the next part of the flow. Next slide, please. So at setup time, meaning when the client first comes online, when it's configured, when it's installed, or when there's a provisioning change, like a new account is set up, these type of things, it would do this one-time operation where it tells the carrier its media capabilities. These media capabilities are like what codecs I support and some degree of parameterization, resolutions, frame rates, that kind of stuff. It's a relatively static set of capabilities. It can be changed, but it's not sent to the server during each call. Super important to understand, and I blew by this point, this is really focused on use cases where we want client to server media and signaling to follow each other is one of the key objectives here. So a lot of, not all, but many IPPBXs, certainly contact center software, which is where I currently work, conferencing all of this variety. Next slide. That's when I'm just about out of time. So the last bit of it is a sort of configuration construct that's in here. Largely, a lot of the details are in there specifically for connecting to the PSTNs. They don't apply to all use cases, but in this case, there's this construct called a TG, which is a wink, if you will, to the old-fashioned trunk group construct, but it's a policy group. And in this case, it defined, the server says, hey, you want to send and receive calls? Great. Here's the set of phone numbers you can call, and here's the set of origins you're allowed to send calls with. And those, in this case, are making use of STIR, and so they use the certificate to indicate what numbers can be called. That's basically the protocol. The protocol is not that complicated. We've got an implementation, which Suhas will talk about, the work that he's been doing, and I've done some analysis. I'm like, well, does this really do a bunch of how much of SIP and SDP and Alpha Answer does this cover? And we also have a draft that analyzes that, and the answer is, well, a lot of it, actually. Because much of what it was doing before gets subsumed by Quick and HTTP and other layers that now come for free in these environments. So I'm out of time, and that's a basic idea of what's behind this protocol and the problems we're trying to solve.
Thanks, Jonathan. I think we could afford probably another 2 minutes on that one, but I appreciate you taking most time. We have 2 people in queue. Mark Nottingham.
Hi, Mark Nottingham. So I have, I guess, a comment and a concern about the positioning here. It's, reading the draft, it's talking about this is just the normal HTTP application, and then the introduction goes on to extol the virtues of being such a thing, which I have to say warmed my heart. Thank you.
I hope it would, Mark.
Yeah, it's a great place. I don't need whiskey today. It's fantastic. But it then goes on to say that it seems like it places a lot of dependencies on HTTP3.
Yep.
And indeed, in terms of multiplexing and then parallelism in the design of the application. And my comment there is that the infrastructure in a lot of the cloud providers and load balancers and other products that you want to depend upon there is not necessarily HTTP2 yet even. There are a lot of folks who still use H1 on the back end, or use H1 for internal hops, and they're gonna, when they upgrade H2, they'll probably use that for a while. So I don't know that this is something where you're gonna really get those benefits anytime in the foreseeable future on the open internet. You're gonna have to very carefully choose components that are designed for this. So I'd be a little careful in positioning it in that way that it's just using HTTP.
Yeah, fair enough. And so let me comment on that. Absolutely. So the assumption here is that someone who's wanting to deploy a voice over IP app using this technology in, say, a Google or an Amazon or whatever, would be like waiting for it to support HTTP 3. And until then, it's going to have to, we'll be doing what we've been doing. So now we're sort of into a race, which is like, well, who's done first? Are we going to finish this protocol and get it standardized and implemented in a bunch of things, or is HTTP 3 going to get deployed into cloud platforms? Let's face it, where things are in standards pipe, you're probably going to win. So
sure. Just realize that HTTP 3 support for when a cloud platform says we support HTTP 3, it's not just a binary. There are many different parts of the ecosystem, and usually when they say we support H3, it means just on the front end, at least to start. And so the second part of my comment then is that you then go into describing these things called byways, which, as far as I can tell, are 20 multiple hanging gets. And that's going to interact really badly with a lot of infrastructure. A lot of folks assume this minutes of a get are a certain way. I think we can address this in iterating the protocol, but again, you look at it and what you're really doing is saying we're relying on web transport for a lot of this. And so it's again, not just an HTTP3 application. It's H3 for a control plane, and as far as I can tell, web transport or some sort of hack for a data plane. Yeah,
and the current draft, we added this later in, so it's easy to miss, in fact, does talk about using web transport if it can find it, and then falling back to this hack, which is absolutely a hack that is meant to deal with the fact that right now, although we have Quick under the hood for HTTP3, there's no datagram transport, which is what we really want. So we're trying to hack our way into it. So here's where I think we need more discussion and collaboration with the WebTrans and HTTP3 groups to sort of get a good handle on what's the right approach to this that makes sense given the likely timelines of when things roll out and just how coupled will these be and so on and so forth. So and there's a bunch of ways. The previous version of this draft didn't have as many hanging connections either. They use more of a round robining technique, and that's what I meant by like there's many ways to skin this cat, and that's the work we'll figure out as we work on the protocol.
Okay, I'll just leave you then with getting that hack right so that it actually works well with HTTP1 infrastructure in all those different places I talked about. Based upon our experience with WebSockets and other things, is going to be a really significant challenge. Yeah. So this will not be easy.
Yeah, and I'm not. I think opinions will be split on whether this matters with HTTP1. In other words, I'm not sure anyone will turn this on or want to use this technology until the supporting cloud infrastructure has the HTTP3 support in it. And that's because many of like all of us here in this room probably have been doing voice over IP know you avoid TCP like the plague, although it does happen. But I appreciate that. Yeah. So we'll have to work that as we get through it and understand, do people want this to work on HTTP1 and 2 or not?
Okay, so Jared.
Sorry, had to get the mouse and the right monitor to unmute. I have a hopefully simple question. So RTP is actually relatively efficient to carry something like the G711 ULAO, a codec, and I'll type it right in the Etherpad. Yeah. I'm just concerned. I'm a little bit concerned. Do we know how much additional overhead this is going to add? Because like a G711 ULAO, which is what most people are probably used to for audio quality, is roughly 88.2 kilobits from my PTSD from running IPPBXs before. So I'm wondering how much additional overhead is going to add once we add HTTPS on top plus all of the additional HTTP headers.
Yeah.
So this because especially upload capacities are sometimes constrained, and whether or not that's going to be a tipping point for a lot of QoS hacks and stuff.
Yeah, so we haven't measured it yet. I think that's something we should go and do, but I'll say a few things. One is this is where the newer HTTP stuff helps because it's binary. There's a lot of optimization that's been added to provide header compression, and as a result, so I don't know how it will be. Probably be more than RTP. It will be less than if you tried to do this on HTTP1 or 2 compared to, I guess it was, where do we go binary? Was it 2 or 3? I apologize. Whichever one went binary by default, like it'll be better in binary than it will in the text version. And it's almost certainly going to be better than if you ran G711 over RTP is still probably worse than Opus over this. So, it's 2 is binary. Thank you. Apologies if I get my what features are on which version things confused. We'll do some measurements, but in general, I also think that there's going to be a lot of use cases where whatever that additional overhead is not a big deal. And so Mark is saying soon to come binary structured headers. So in general, HTTP is working on this stuff a lot, so I expect it won't be a big deal. All right, from the chairs, do we want to go to the next presenter, or we want to take more questions?
Yeah, so let's make this really quick. I think we have Echo and then Justin. We have a couple more. I'll let David in as well.
So this may be, Eric or Squirrela, this may be something that like actually needs to get worked on, but like when I read these drafts, they seem to embody a really quite odd set of assumptions about what parts of the ecosystem are like invariant and what parts of the ecosystem we're gonna like assume will be changed, and that like, you know, they seem to assume that we're going to have quick, but that like none of the other parts of the system are going to be variable. And yet they seem to not assume that we're going to have to like run over H2, which we have to do like essentially perpetuity because like quick doesn't get through like a really large fraction of the firewalls in the world. So, you know, I'd like to sort of push on those assumptions at some point, but we can do that later.
Yeah. So, so hey, Edgar, good to see you. Chat with you again. So the answer to that is that it sort of makes this assumption that the cloud infrastructure for web will generally follow the path of web standard work. So at some point, HTTP 2 and 3 will get rolled out. I don't know how long it will take. It'll take some amount of time, as we just talked about. And so what we don't want to do is, so it's okay. The assumption is it's okay to sort of wait for that, because again, the usage model here is that as an application developer that wants to deploy a VoIP app in public cloud, you will know whether or not the infrastructure has yet gotten support for HTTP 3 and any of the features that are there, capabilities that Mark was talking about. And you would simply just not do this unless you didn't care that much about latency, in which case then you can make it work with HTTP 2. So you would sort of wait for that. And then besides that, we want to sort of be we don't want to be different from the web. We want to be looking as much, and I don't want to make a 100% or 0% statement. Maybe there is an extension to HTTP, a small tweak we go and beg Mark to jam in the spec before it's finally done to make it work for real time. But like the goal is to minimize those. The goal is to make it work as a web app so that when these reporting infrastructure catch up with the standardization work that's happening on HTTP, we're able to start rolling this stuff out.
Sure. Well, I don't belabor this too much, but it just seems quite weird to assume you're not going to have datagram, but you are going to have universal UDP penetration, given that we know the second one is false. And yeah, datagram is very close to done. So
listen, if web, that's what I'm saying. Like this is the work ahead of us. Like if it turns out that web transport is coming sooner and will be widely supported and is supported well in these cloud platforms, and we don't need to. We should start with that, then that's cool. Great. I know I'm not sure, and that's why the spec at the moment actually uses both.
Okay. Well.
But what's not well supported in public cloud is just using UDP alone.
Yeah. So Justin.
All right, just trying to unmute here. Yeah, I just wanted to speak to two things. One about the deployment situation, and two about overhead. One. As Jonathan points out, the current deployment situation is you have to basically build everything yourself. There's no cloud server support except for VMs. So the fact that H3 support isn't fully there yet, like I don't think it's a huge deal. It will show up, and even if you have to support, falling back to HTTP2, in certain situations, like on major internet services, we're seeing a single-digit percent of connections coming in over HTTPS instead of using UDP. So it's certainly possible to make this stuff work, in a fallback scenario. As it relates to overhead, RTP has some amount of overhead in it, like the way extension headers are done are one particularly sort of weird thing. I think that with some optimization, we could get it so that there's no more overhead of like putting RTP inside quick. It's actually sending RTP by itself. That's all.
Okay, James. Oh, he's dropped out of queue. Sorry. David, one brief comment, please.
Actually, not a comment, a clarifying question. This is David Skenazy, chair of the WebTrans Working Group. I didn't read through the entire doc, but went through enough of the background introduction, but I'm still missing something.
Sure.
This new Ript protocol, would it be implemented inside JavaScript? Is this something that you want to do on the web, or is this a separate thing?
Yeah, so there's a bunch of different deployment models. One of them is that it would be implemented in browsers. There would be a split. I think that's exactly how that would be split between the JavaScript app and the underlying browser is TBD. But that's only one of the use cases. The other ones are like, I had this slide before that had the 5 different application areas. A bunch of those have things on both sides that aren't web browsers or at all. They're just like server software. So I write a Java app that I deploy in some public cloud environment that does some voice over IP stuff, and it needs to send a call to a carrier, and the carrier is deployed in SBC, such a border controller, and one of those SBCs has implemented this protocol by taking an HTTP3 stack and then integrating it into their product however they want. So in that case, there's no browser at all. So the assumption is it's implemented in servers that are will often be using an off-the-shelf HTTP stack. I doubt they're going to rewrite that, but it isn't just on the browser.
Okay, thank you. Because then the follow-up very short comment is the #1 goal of web transport is to take things that exist in the transport, like quicks, let's say datagram frames, and make them accessible to JavaScript. So the kind of only reason for being a web transport is to enable the web security model. And in this case, if you're not limited by the constraints of JavaScript, as in you can implement this in C in the browser or outside of any browser, then I'm not sure what you're getting out of web transport. So, but happy to take that offline.
Okay.
Okay, great. Justin, you're up next. We're about 5 minutes behind, so let's keep as many questions at the end held off until the very end of the slide sets, if possible. Go ahead, Justin.
Okay, I'll try to blast through this. So I just want to talk a little bit about our implementation experiences at Google. Sort of the image here refers to the fact that we basically had to forge our own steel when it comes to standing up like a server-based RTC application. For HTTP apps, there's like a ton of stuff, as Jonathan mentioned, in modern cloud providers. If you basically just want to like send some RPCs and do your business logic, you can basically go implement your business logic in a container and deploy it into the cloud very easily. You get high availability, you get failover, you get built-in monitoring, authentication, all sorts of stuff. When we built the first version of the reference app for WebRTC, and there's a little distinction here I'll make about like what this means when we say an RTC app. I was able to get that stood up in less than a week, and that was like being new to App Engine. The reason why we were able to make this work is that this is a peer-to-peer WebRTC app. No media actually had to be sent to the server. This is just media going between peers, and the only thing that had to happen was signaling going to the server, and that's something that HTTP does really, really well. Next slide. But for something like Google Hangouts, you have the signaling going over HTTP, but you actually also have to send media to the server, and that goes over SRTP or ICE, or maybe using DTLS if you're using data channels. And all that stuff that you got for free from the cloud, now you need to go build yourself. You need some sort of load balancer, something to protect you from DOS attacks, something to do sort of failover, routing you to the right machine, stickiness, framework to actually run and scale up your services, and be deployed in lots of data centers around the world. And then after all that, you get to actually work on your actual business logic. And things like tooling and authentication, metrics, all that stuff you also have to build yourself. Even in the browser with WebRTC, like the built-in browser dev tools don't show you anything. We had to build our own WebRTC dev tools. So this is the kind of thing where if you're building like a conferencing service, you need to be prepared to invest in literally dozens of engineering years. Next slide. So this is what the protocol stack ends up looking like, for WebRTC server-based applications. You actually do your signaling over HTTP, TLS, TCP, but then you've got all these other protocols in the mix for data and for media. And on the client, we've got WebRTC in the browser. You know, we also have WebRTC libraries for mobile. Like, it's not that big of a deal. But on the server, getting these stacks kind of deployed and really tuned out for a server-side deployment ends up being pretty challenging. There's really not that many of these implementations, and people spend a lot of time trying to get the existing ones to work well. It's just pretty complicated. Next slide. So here's kind of my hope that we could eventually get to a state where with Quick and H3, we could get to this thing where we can basically have a common protocol and common infrastructure for a lot of these different types, for signaling, you know, for data and for media. And overall, like, we get a lot of reuse, and there's just like a ton of really good server implementations that people can choose from. And we get all the nice sort of benefits that Jonathan referred to: metrics, logging, authentication, failover, high availability, et cetera. So the question is, well, why do we need to actually standardize this? You know, we've got a bunch of great work happening in web transport. That's going to be standardized. You know, what do we actually need to do here? And, you know, web transport gives us a nice, you know, sort of set of primitives, but we also need to figure out how we actually are going to expose web transport, you know, in cloud providers, so that you could actually get all the stuff plumbed through, you get all the nice sort of benefits we are hoping for, and also figure out how we can get the performance we want when setting media flows, where the congestion control needs might be different than what you might just have in Quick by default. It also would be nice if we could have some amount of interoperability between services. If I have a smart TV and I want to watch a live broadcast that's being basically streamed down over this protocol, I can just get a URL and I can start consuming it. And same thing if I have like a IP camera or something and I want to go push that into a cloud provider, it'd be nice if like there's a way that they could talk to each other without having to build a whole lot of logic themselves. So that basically says we need to figure out the media format as well as some sort of basic signaling so they can get the stream started. So what we standardize? Well, at a minimum, I think we want to standardize how we actually deliver media over H3 or web transport. You know, that's what is the wire format? Do we want to pack RTP inside of web transport? Do we want to try to put things inside of quick streams? And then also, to sort of Ecker's point before, what mechanism do we want to fall back to when like H3 is not available? Then beyond that, if we want to have interop between different providers, we probably also need some HTTP-based signaling mechanism. And that could be a bunch of different pieces. First, the mechanism to actually send RPCs, you know, in a sense, something like REST, gRPC to say, hey, perform this operation. Then secondly, the actual logical operations themselves. What do you do to start a stream? What do you do to stop a stream? What do you do to request events on a stream? Then third, like media descriptions, you know, our favorite punching bag, SDP. How do you actually describe, here's what I can do, and you know, let me see what you can do. And then finally, like their, you know, other punching bag, offer answer, you know, what do we do to say, hey, I want to basically start watching this live stream. How do I intersect the capabilities that I have with the capabilities that the server is providing? So those are basically the areas. We could focus on just number one if we just want to get something done. But I think that there's also a variety of things we could do if you tackle number two, where you allow, like, you know, different cloud providers or different clients and servers to interoperate. Anyway, I think there's a lot that we could do here. If we'd had a bunch of this stuff 10 years ago, it would have made my life a lot easier. But that, even though we didn't have it, I think still be really valuable to the internet to provide it now.
All right, thanks, Justin. Oh, we see Harold just made it in time before I get to the next one. Harold. Harold, do you want to wait? Harold seems to be having audio problems. If you want to drop that in, Mike, on the Java chat, we'll relay it.
Okay, if no more questions, let's go on to Anthony.
Hello, can you hear me okay?
Yep.
Okay, so next slide. So I'll just give a quick background. I represent FreeSwitch. It's one of the most likely implementations of this protocol if we go forward with it. And so I'm Anthony Manasale. I'm the author of FreeSwitch. It's a popular open source tool. You may liken it to like Nginx or Apache to the web server for VoIP. FreeSwitch runs in any environment on software and converts various different media protocols to and fro. Terminates WebRTC, SIP, H.223, all types of codecs, all types of formats, and is a pretty important building block in a lot of different IP telecom solutions. So, next slide. The reason that Ript's interesting for our case is that over the years, our platform has been used extensively to build lots of different high volume telecom cloud services. You know, and that almost always involves SIP. There's a lot of other protocols, but SIP is predominantly the most challenging and hardest. It's probably like the biggest module that we have in our software stack. And it's been, you know, try every single way possible to scale and to make it bigger and to put it in different microservices. And, you know, the more and more people are starting to create in Dockerized instances, networking is getting even harder. So finding a lot of people ripping their hair out, trying to figure out, like, how can I scale my telecom and how can I utilize the, you know, like cloud hosted services? You know, even SignalWire, we build cloud hosted services ourselves. So, you know, we have the expertise to kind of bundle some of these things, but it's not very easy in general. And it's also like a really interesting way that I think that we would be able to terminate, you know, like high volumes of traffic. So being able to do that will kind of solve a lot of problems that the original SIP thought it was going to solve. You know, I always used to curse while I was implementing our SIP, you know, because it looked like it was copying HTTP so that it could copy the paradigm of how the load balancer used to work in the Web 2.0 days, but then it kind of diverged and never got to do it. And I really think it's kind of at least nice to see the HTTP evolved and now, you know, trying to come back to leveraging that instead of having 5 million different setup protocols. So that's one really important thing. And, you know, there's just like the way that we do things on the internet has changed a ton. And some of these techniques are from old days when we had hardly any bandwidth and like things that are kind of outdated now as far as how to deal with the situation. Next slide. So an example of how it would look in our world would be basically there's a module that loads into our core, which would accept, you know, the H3 connections. Once there's a trunk set up, most likely it would be using that more advanced mode where you'd be, you know, connecting to another server far away, coming from like a provider or maybe another node in your own large network. And you will say adding and removing channels from that trunk, which will then turn into, in our soft switch, logical channels that you can operate on. So you can kind of behave more like a normal telephone switch would, without having to worry about it. Then from there, you can turn things into SIP still. If you have like legacy world where you have a bunch of older things, you know, it's kind of what we've been doing forever is combining the future and the past so that there's still a bridge between them. So that'll still give you, you know, like you won't even have to really know too much about the rest. You can still develop applications, everything the same way without having to even really worry about the protocol too much. Next. So there's some issues already. I know, like, I've already seen a bunch scroll through the Jabber, and some of them are probably true, and there's a lot to talk about. There's going to be, especially in the world of telephony, it's just super complicated, and a lot of the stuff is hard to get right. And for us, I think one of the hardest things is we build everything in C, and I'm not sure, there's only one HTTP3 stack I've seen so far. I haven't looked at it yet. But in order to pull this off, I think we need that first. There's going to be like keeping everyone happy with the, you know, the end users of calls are all very abstracted from this process. They're usually just people answering phones going, I don't understand when things don't work. So it generates a lot of pressure, goes uphill, and, you know, the end experience has to be preserved. And there's a lot of little aspects of telephony, passing metadata through and whatnot, that have to be considered. Next. So what I think that would happen in order to do one of these implementations, which I think that we're kind set to do one of the early kind of implementations that would scale. But first we would develop a stack probably in its own open source library to kind of abstract some of the concepts. And then once we did that, anyone else that was interested in doing C-type stuff, because there's a lot of other open source tools and whatnot that might be interested in it. But we would then take that and use it to make a module into FreeSwitch itself as the project. And once we get that far, then we would probably be able to kind of test it in the wild. It would be great to actually have some kind of tests ahead of time. I spent a lot of time building VoIP protocols, and they all existed before I started, so I had no say in it. So kind of cool to actually be able to have a chance to figure out things before they're ratified. And so, yeah, the other thing I think will be tricky is figuring out how to go, to be a back-to-back agent, or I think gatewaying to other protocols. There's going to be some considerations with the way the media changes and whatnot. So that's all.
Thanks, Anthony. Is there any questions for Anthony's presentation? You have until the next presentation gets on the screen. Which is much longer than I expected. Suhas, are you ready to speak?
Yeah, I'm ready. I think it's doing a go-get now. Okay. So this is Suhas. I'll try to kind of give my experience of implementing the Ript stack in the Golang. It's not complete, but it's a work in progress stack. The URL for that is right there. So just to give a background, I've been kind of working at Cisco, trying to develop a product that kind of pushes the media over HTTP2 using gRPC and have the server being on Kubernetes on a couple of the major cloud providers, and being able to kind of get all the benefits that cloud provides, like what Justin and Jonathan mentioned. So for us, Ript is basically a natural evolution of moving from HTTP2 to HTTP3, and hence my interest in getting this work. I am hearing that. Is my audio coming clear?
Yeah, there's a little noise. Like it's an odd noise, but you're fine. Carry on.
Okay, cool. The scope of the Ript protocol, which is a Golang-based Ript client and server, is basically try to implement what is in Ript spec, parts of the Ript spec as it stands today, to see if it's really implementable or not. So some of the concepts that I was interested in trying to see was how does the media over HTTP3 works? Like, can I use put and get to really stuff my audio from the client to the server to the client on the other side, and also have the server deploy it in the cloud and see, can we get HTTP working through the cloud, which is one of the major concerns we had, like, can HTTP work today? And magically it works, in at least in the test deployment that we had. And also really see on terms of the performance, like the latency versus the bandwidth that it takes, and also try to experiment with some of the signaling aspects of the protocol with respect to run discovery, handler registration that like Jonathan talked about. And eventually we would want a running code to actually influence the spec as much as possible, and also take this running code into the real product, which I'm working on as well. Next slide. So this is the deployment we have today. We have the Ript clients, which is written in Go. We use a quick Go stack that's open source, and port audio for the audio. And there are two clients, and the server is being deployed on Amazon EC2 instance. There's a public IP. We would like to put it on a private network eventually, but there's a public IP for that, which has Let's Encrypt serving all the certificates as required. And we have the both clients connecting to the server using a single quick connection and using HTTP3 streams to kind of send the signaling messages as JSON encoded format, and send binary, which is the audio captured with O for compressed as media packet sent, or as with binary encoded as well on different streams, or the same quick connection underlying. Next slide. So I'll not go into detail of this flow. This is exactly the three flow charts that call flows that Jonathan showed being combined in one place, which kind of shows what the prototype provides today, where the clients like Alice and Bob, and the server is in the EC2 instance, both clients basically they discover the trunk they want to connect to, and they register their handlers, which is basically the devices with the media capabilities. They advertise what can they support, which is Opus today. And once they both register with the server, one of the media sender basically does a /calls API, which is and to initiate the call, and the sender basically uses HTTP put to put the media packets, and the receiver does HTTP get to get the media packets, so that between sender and receiver we can have pure H3 based media send and receive happening. Next slide. This is a textual format of what I presented in the previous slide, so we can skip the next one. So, like, one of the things that when we started trying out the Ript spec was to see how complicated is it to build something like Ript today, and it surprisingly it was fairly simple to build. Like, as you can see, that the total amount of lines of code that we wrote to get the server and the client does not cross 2,000 lines of code, and which is like total. It's work in progress, non-optimized, and it's not clearly designed. So you can assume you can still optimize it better. But this was implementing some parts of the spec. I could definitely say that building something like this was pretty simple, and not much of number of days was involved. And another thing is that the reason for this is because most of the complexity or heavy loading is done by the underlying Quick stack, which, like the Quick Go, provides HTTP3 for us for free. So only the business logic that corresponds to the Ript has to be written, and that's not really complicated. And we can from prototype we can see it's fairly easily done. Next. This is like rough estimates on the latency and bandwidth. Since we are sending the media or HTTP3, and with Opus it compressed 16 kilohertz, 20 millisecond frames, roughly around 48 kilobits per second. And what we see with respect to the latency, one thing that we saw is that we use Cullen's lab and in its basement to kind of have the sender and receiver running in Calgary, and our server, which is running on EC2, running in Oregon US cluster. And then the network latency from the one-way latency from the sender to the receiver, we measured it was averaging between 35 to 50 milliseconds in general. And from the mic to speaker, from the sender's mic to the receiver speaker, overall latency was around 350 milliseconds. Just for curiosity, we also did a test for the WebEx and wanted to see the measurement. And surprisingly, it was almost around the same numbers. Probably one was 348, another was 352, but you can say it was approximately around the same numbers. So we do feel with a quick and dirty implementation, we can still get the latency and performance measure experiences which matches with existing systems today, and probably with more careful thoughts put in, it can be made better as well. Next slide. So some credits, QuickGo is the stack that we use for H3, and we used TLS 1.3 syntax library to binary encode the media chunk format, and we use Go port audio for the audio. We have a couple of more slides. I think. Next slide.
So House, if you can make this very quick, we need to move on.
Sure, I think we can skip because this is good enough. This is for extra credits.
Okay, thank you. We have one person in queue, Watson.
Were you able to get two servers working and get all the benefits of the load balancing, et cetera, from the cloud deployment, or is that yet to come?
Not yet, because this is just 3 days of work. That is what next thing we would want to try, putting it behind a load balancer and try to see if we can get that happening as well. Yeah, that's something we would like to try as well.
Okay, Colin, you're up.
Okay, so I just want to walk through the charter here. Next slide, please. So I want to just identify that as we're going through the charter, I got 2 slides at the end specifically to talk about peer-to-peer media and end-to-end crypto, because those are the 2 biggest topics that have been raised. So we can hit. I just want to say that we've got that. There's some trivial changes that have happened on the charter since from what was posted to the list. I highlight them in the charter here. So with that, let's jump right into it here and get the first slide. So, I think we've tried to clearly explain the sort of the overall infrastructure that we're going at and the motivations around going it and pushing this over media. And it is, the charter tries to be clear that it's trying to build this on top of H3, that's the real thing, that there would be some fallback to something else, but the primary thing is a design goal around making sure that we design something that works on top of H3. So I'm going to pause here for a second, see if there's any questions jumping in the queue about this slide. Okay, next slide.
We have one. Oh, Eric Roscola.
Yeah, so I noticed that you said H2, but this slide did not say H2. It doesn't say anything about fallback at all, as far as I can tell.
Fair enough. We could update that, and I think there's a later part in the slide in the charter where we do hit H2, or maybe it was just in milestones, which wouldn't work. It'd be charter text. I don't know. Thoughts on that? What it should say?
I mean, I think that what it ought to say. I mean, I guess like as I was saying earlier, and I think Justin and I had exchanged on Jabber. I mean, my thesis, and if someone wants to disagree with me, they should do that, is that you want this to work universally, and the situation is not that you can get UDP through every firewall in the world. And so it's got to say something about how it works in a situation where you don't have UDP penetration. And if we agree that's H2, then okay. And if we want to say it's got to work in that case, then okay. But it's got to say something, right? So I think that's really what I'm arguing for.
Okay.
If you think the facts are wrong, by all means say something, right? I mean, I'm totally happy you're wrong.
I think that Justin's use case that needs to get through lots of firewalls for sure, right? And not all firewalls, because there's no way H2 gets through all firewalls for passing voice, right? So, I mean, I think that you're always talking about most, not all. But a ton of the use cases, there's no firewalls involved at all. It's cloud-to-cloud use cases, right? And it's pretty wide open. I do think, though, there's large discussion about a fallback, and we should say something about what it is here, and maybe that's something we should get a little more clarification on of what that fallback exactly looks like. But I think that mostly people have been talking about H2 fallbacks, but maybe it should be something else than that. I mean, Mark Nottingham having comments on that too. I mean, do you have feelings on what the fallback should be, what we should say there?
I mean, Mark should be here next, but I guess I would have assumed it was H2. My real thesis is it has to be TCP, right?
Yeah, it has to be TCP. That you're right. That's the heart of it. I agree with you. Yeah.
Okay, Mark Nottingham.
What do you know, Mark Nottingham? Yeah, so this was talked a lot about in DOE and in other places and in BCP56. The problem with specifying a particular version of HTTP, whether it's H3 or you say fallback to H2, is that you don't control every hop in the chain. And even when you think you do, you don't, because there could be things like virus checkers and filters in people's browsers. And one of your stated use cases is to do this from the browser. And so you can optimize the protocol for later versions of HTTP, but you have to be pessimistic. You have to realize that sometimes it's going to fall back to HTTP 1 and it still needs to work.
Jonathan.
Yeah, so I put some suggested text in the chat and I got spanked immediately, so apologies. But I think I'm suggesting the words operating on top of HTTP, but optimized for HTTP 3. And notice I said operating on top of HTTP, not HTTP 1 or 2, but just HTTP. To Mark's point.
Okay, thank you. Stefan.
So unrelated to the HTTP version of
I'm sorry, Stefan, you're really garbled. Do you want to try rejoining the queue? I can't make that out. Sorry. Maybe put your comment into the Jabber chat. James.
Well, this might be a little left field. I think that we should also be considering not just telephony use cases as well, and also consider broadcast-based use cases, because inevitably the two mix when you think about things like video conferencing and all the rest of that stuff.
Do you want to respond to that, Colin?
Historically, these have not mixed that much, in that the way that people want to do the broadcast ones are give them options, a lot of options that you don't have to take here. Though, yeah. So I mean, I think this would be usable for broadcasts, but I think the broadcast people. But I think what the broadcast people need are solutions that are much simpler, that don't require the problems that happen here, so they may not choose to use this. So I think that's why broadcast hasn't really driven any of these requirements yet, is they're already fairly happy with their Dash-like systems, which have many of the properties we're talking about, right? They work through load balancers, they're HTTP based. Much of this was driven by the type of stuff HLS and Dash.
Sorry to clarify, when I mean broadcast, I think more on the what we would think of as the contribution side. So, we've got.
I would consider the contribution side of broadcast real time. There's nothing. It is real time application, right?
Well, yeah, I guess. But I guess okay. Maybe a better way of rephrasing my thought is perhaps we should consider non-bidirectional use cases and consider unidirectional. A previous speaker,
yeah, for sure.
Earlier mentioned surveillance cameras and other such use cases.
Right. Okay. So I'd be perfectly happy. I mean, I think unidirectional is very much in scope of what people are thinking about here, from what I've heard in the charter. So maybe we should clarify that it's both unidirectional and bidirectional real-time communications. Would that work?
Yeah, that works.
Okay. Anyone have any objections to that?
Well, let's hear from them. Harold.
Let's see if the mic works this time.
Yes.
Great. So far, the real big question is, are we building a system which has to pass the media over HTTP or not? I mean, if we have to pass the media over HTTP and with real-time operation, then I have a hard time seeing that working over HTTP1. So that is a critical point for which HTTP version we aim for.
Okay, Stefan, do you want to try talking again?
Yes, please. Better? Is this better?
Yes, much better. Thank you.
Oh, great. My apologies. I continue to fail to understand, and I continue to be unconvinced by the answers that were discussed on the mailing list, that you can't separate signaling from call control in this new protocol. I would prefer to have these two things handled separately. I think the main argument that I heard is fate sharing. This is not, to me, not a convincing argument. Thank you.
If there's any suggestions you have for how to frame that in the charter, that would be interesting. But I think that discussion will have to continue on the list.
It's relatively easy. So the first sentence of the chart.
I don't want to do the design right here. Let's not do that. That's a fine comment. WebRTC largely addresses that.
That's exactly my point. What the charter does right now, it prejudges a design decision, which is that there is one protocol that does both signaling and media transport. And I would like to have the freedom to have these two things being handled separately.
Okay, so I just speaking, I think for many of the proponents of this, the tying those two together was that the signaling follows the media has been a very key tenet that many of us believe in, and that's what we're proposing here. We understand there's systems that are built differently. We were deeply involved with those, but I don't like having talked to a ton of people about that, that's like one of the key things they want to have happen here, and the reasons why are the reasons that they put out about the load balancers, about leveraging the HTTP environment, all of those things. So I mean, we can propose that or something, but that is, I do not think is a change that's acceptable to a lot of the people that are pushing for this charter. Right? And that's why the charter still says the same thing it has for a year now.
Okay, I take that under advisement. I'm still unconvinced.
Okay, that's fair. I mean, I understand unconvinced, but yes.
Okay. So Bernard, please. And by the way, the queue is closed. We're going to try to move through all of these slides, and we'll have general discussion later on.
I wasn't going to comment on this. I was waiting till later, so go ahead and you can bring me back.
Okay. The only other person I have here is Eka. Do you want to talk about this slide?
I think so, but I'm not sure because this bidirectional thing got me confused. Does the current document still only facilitate outgoing calls?
I believe the inbound document talks about incoming calls, but I'm not sure how it actually works.
I guess my question, my real question is the intent here to have both incoming and outgoing calls specified by this working group?
Yes, it is.
Okay.
But Ecker, the bidirectional thing too, which it would be a call regardless whether it was incoming or outgoing, like something like a CCTV security camera that only really sent media one direction. Yeah. Okay. Cool.
No, I understand. I'm trying to figure out. I'm trying to make sure I'm trying to understand what the proposed scope is. But if the proposed scope includes incoming calls, then I'm not going to complain about that.
Yes. Okay. Next slide.
Are you able to see that, Colin?
Yeah, it's here. Okay, so two major different parts of the slide. One is about we're trying to hit a set of functionality that's in widespread use today, not everything that we ever could do that's been defined in various SIP things. People have pointed out that widespread usage is extremely hard to define. And I'm sure there'd be a lot of wiggle room in the working group to try and do the right thing within trying to figure out what that means. But we couldn't come up with any better words for that. So that's why those words are still there like that, even though people have pointed out they're not great. The next parts of this are really about the security portion of this. Much of the authentication and various parts of it are just exactly copy the web model wherever is possible. There are some parts of it, like the caller ID, which mandates the usage of the passport things from STIR to try and have a strong identity in it. And we think that that's moving the bar up substantially from what we've had in other systems and trying to get that right, and that we can get that right now. And then this discussion about this E2N, the end-to-end stuff in the MLS, I'll push it out to the end because I think we need to spend a bit more time on that one. But that's where this point is. That's what currently says in the charter, and that's where this point is. So let me stop there and take questions about this slide.
Okay, Eric Scola.
Don't worry, I'm not here to argue about end-to-end, but I am here to argue about removing the phrase notably OAuth. This is web or it's not, but let's not enshrine the idea that web authentication will be OAuth for all eternity, right? I mean, there's web authentication, which should be how web authenticates itself.
Yeah, okay, fair enough. How should we phrase that?
I would just remove that parenthetical.
Okay. Yeah, okay, that makes sense to me. Any objections to just removing the notably OAuth?
+1.
Okay.
Colin Perkins.
Hi, can you hear me?
We can.
Excellent. So I would certainly agree that you do not want to replicate all of SIP in this protocol. There are many other signaling protocols, though, and one of the things which has affected a lot of previous efforts in this space has been scope creep. So rather than saying we don't want to replicate all of SIP, we may want to be a little bit more clear about what features of the signaling we do want to replicate.
Yes.
I think Jonathan wants to answer that question. Jonathan.
Yeah, so Colin, listen, we're immediately worried about the same thing, and so I went and I did a little analysis, and I don't pretend I got it 100% right, but I think I got it probably pretty right. And I looked at the core specs, 3261 through 3265 at least. And interestingly, so much of those protocols are now subsumed by stuff that would be provided by the lower layers, that what you see in the current Ript draft, like I do believe it would more or less replace 90%, unless maybe even 100. I'm sure I missed something of what's in those. And then I at least scanned. It took me hours, like days. I made a spreadsheet of like all these SIP extensions or whatever, and went through them. Like I exited that exercise, and I hadn't written it all up, feeling like you'll be shocked that it is not that hard to cover a lot of what. It isn't everything, like, and we'll get to some of those, but like a lot of it is just subsumed by these lower layers, and then we don't need to address them. So that's why I feel like this is doable. If we were repeating it from scratch, meaning we weren't building on top of like 10 years of HTTP standardization, I would feel different. RTP is a different story.
Yeah, I'm just I'm nervous because I saw the way the PSTN interworking affected the SIP standardization, and I don't want this group to go the same way.
I'm not debating that scope creep is a worry. It's just hard to put a very mathematical boundary around it, and that's why the best we could come up with is like, well, we're not going to re-implement stuff that no one ever implemented or cares about. That's one obvious thing. But there's a lot of stuff that's very application specific, like all the IMS headers. Like I don't think those are in scope, and that they're unique to a very particular deployment inside a particular network where no one is currently planning on replacing SIP there with this thing, so we don't have to redo those.
Yeah, sure.
Okay. Next slide then. Oh, Robert Sparks.
To provide a really extreme example of the kinds of things that I think Colin is worried about, just so you can run it against the analysis you did, Jonathan. I could envision, especially since we had the comment about the one-way media application, someone coming along with a requirement to insert the appropriate commercial at the appropriate time in this stream. So, listen for foul words and cut them out if there is a foul word removal service. And that's the kind of creep that having some kind of charter protection against would be useful.
Yeah, and for that one, I believe it is not in scope, and it's a good example where you would mostly be interested in that in the client to server leg, and if you make the browser client assumption, that's the kind of stuff that would be handled at the application layer, and there's no need for it in this protocol. I would love to figure out a way to draw that box easily, and I'm open to what maybe you have some good words to suggest. Basic call signaling and establishment. I mean, I don't know. Even that's debatable what it means. Do you have some suggestions on wording?
No, not in real time.
Okay, thanks.
Okay, one short comment from Bernard, and then we'll try to move on to the next slide.
My overall comment is there's a lot of different problems in this charter, like there's a media problem, like how to send the media over quick, or HTTP3, and there's end-to-end encryption. And then there's a whole bunch of signaling stuff, and then there's kind of the peer-to-peer problem. I think you can only choose maybe one of those big problems to solve in this working than trying to do all of them. Just a thought.
I think a lot of those are very deeply tied together, and when we try and pull them apart, we get ourselves in a lot of trouble when we start looking at this stuff. And maybe not all of them 100%, but I think the essence of the end-to-end encryption discussion is going to come down to, you can't leave this till later and wish it away, right? You need to do something. So let's jump on to the next slide here for a second. The key point of this part of the charter is that this doesn't imagine it being done in both browsers and non-browsers, right? And as well as servers. Many of the use cases, for example, talking to Google's ASR engine is purely a server to server, or I mean, who knows? It's client and server in the HTTP sense of it, but both the client and the server are running in cloud data centers. Right? And in some of the cases, the clients are running out on end users' computers near the edge, mobiles, apps, browsers, etc. The second part of this was really around the configuration necessary. As we dug into that more, that's mostly around managing the identity of what phone numbers can you use, what identities can you use, how do you sign them, how do you put them up is the second part of this. So
okay, we have Sanjay. Did you want to comment about this slide or the previous one?
Actually, the previous one. The question I had was on the, if you go back one slide, Colin. So the last statement, I think it's very critical given where we were with SIP and, now what we have done with STIR to mitigate some of the issues that actually we had with SIP. So I think it might be worth not to design something here, but something that is more explicit than what we are saying here. That this extension will also utilize STIR for caller ID. Maybe a little bit more clarity might be helpful, not to wordsmith anything here, but something that is more explicit as to what this will do.
Thanks, Sanjay. If you have a suggestion for specific text there, I'd suggest maybe taking that to the list.
Okay.
Thanks. Eric Rascola.
Yeah, thank you. I think Mark and I probably asked the same question, but when you say implemented in browsers, do you mean that it's implemented in like the C++ in browsers, or is it implemented in such a way that it can be implemented by the JavaScript code running in a browser? Because those are extremely different things.
I'd like to let Justin take this call, but I was deliberately vague between those two things, and it depends whether web transport exists in browsers or not before you can answer that question partially. So
I'm willing to give you web transport in the browser for the purpose of this discussion. I'm going to spot that for you.
Yeah. Okay.
Much as possible and put this into the hands of applications. That we've got web transport or something as a primitive, and then all these sort of things. We don't need 4 dev teams to all go do a whole bunch of heavy lifting before people can start taking advantage of this.
I'm sorry, Justin. I mean that certainly seems like a good. That certainly seems like a good theory, but I think it's probably a little more precise than that because so one theory would be that it has to be implementable in an unmodified web browser that doesn't have anything other than web transport, right? And that would require, and that would place the requirements, for instance, on what HTTP mechanics you can and can't use. And so I think we really do have to understand if we're targeting that or not.
I mean, I would basically say if you have web transports and web codecs, you have all you need to make this work.
Then this document
maybe there's okay.
Sorry, go ahead.
I mean, we might find some things, down the road where it's like we need special flags on fetch requests or something like that. But for right now, I think those are the 2 primitives I've been assuming are what you need to make this work.
Well, I guess I'm trying to figure out distinguish between would it be nice if that happened, or would it be is it a requirement for the design? So I mean, because one might imagine putting things in, I mean, accidentally or intentionally that made that impossible. You need a new HTTP verb for it or something, right? And so if we're trying to design with that in mind, and I agree with you that it should be possible, but if we're trying to design with that in mind, we feel down that it needs to be possible, otherwise people will forget, right?
Right, sure. Well, I think that when we say should be implementable, we should say, by JavaScript applications using nothing more than web transport and web codecs. Or, we could even just say, without saying nothing more than, we could even just say web transport and web codecs as the primitives we built on top of.
I'll have to think about that, but thanks.
Thanks. Mark Nottingham.
Yeah, so Ecker asked the first part of my question. The follow-up is, if it's available from browsers without any modification, how does this affect the threat model? Are we going to have advertisements, with malware in them making 400,000 phone calls to my number now? Because it's available to every web browser on the web. I'll just leave you with that.
That's a little funny there, Mark. I mean, you got something beyond what WebRTC allows today. I'm missing the problem.
Well, so WebRTC wasn't just implementable by any web browser. Right. There was an API exposed, and there was a lot of work put into the threat model for that to make sure that it was reasonably contained. But if I can just write some JavaScript to make a phone call effectively, that's a very different thing.
I don't think Justin for a second was proposing that, you know, so I'd be able to some JavaScript would be able to access your mics and whatever. Your mics and the cameras and speakers with, you know, without some sort of permission model and all of that stuff, right? I mean, it was, you know, it's the whole web codex discussion. So.
Right. Well, I actually wasn't even thinking of that side. I was thinking on the server side. You know, are the servers going to have the discipline? You know, they're not maybe used to this threat model where any random web browser can open a connection and request a phone call. Is that going to be different for them?
So you know, everybody that builds a server that allows you to make a phone call and some communications to it is certainly going to want to authorize and figure out how to do that. I mean, but I'm not seeing necessarily changes. I mean, how many people calling now connected through a web browser and it authorized them and decided whether they'd let them in or not? I mean, I don't see that change that.
It's a difference in scale, I think.
Yeah.
Okay, Jonathan, did you have an answer to that?
Yeah, so I just wanted to say, this is sort of, Mark, one of the reasons why the client-to-server media also makes things a lot easier. A lot of the challenge with WebRTC was like, oh, I can tell the browser to send media anywhere to any IP address I so desire, which is like a ginormous DOS hammer, because Ript in its current design focuses on, you know, it's just it tries to reuse the web security model, right? You connect to the server, and that's where you send stuff. There's no ability to target, you know, random places or what have you that are different from where the browser's going to. That doesn't address the access to camera and mic problem, but that would be what remains, is just access to camera and mic.
Okay, thanks.
Please continue, Colin. Yes.
Okay. You know, I mean, I think as somebody pointed out, this is heavily dependent on a working group that was just chartered, depending on a draft that, you know, is still in. I mean, obviously, we're like this whole idea, even on Quick, it's not just Quick. We're relying on the datagram stuff and Quick working for any of this to make any sense at all. So there's a bunch of different working groups to coordinate with here, and there's a lot of work that this layers on top of, dependent on finishing too, like work that's still in flight before this really gets that far. So any other comments on this slide? And this is the end of the chart, or we'll jump into some of this stuff. There you go.
Okay, Miriam.
I'm Mia Cleveland. So I asked this question in the Java, what is the actual dependency on web transport? Because that's for me the worst dependency. Quick is kind of more or less hopefully done, but web transport just starts. Is there an option to like not have web transport and add it later, or is this a strong dependency?
I think that as this call went on today and David's comments earlier, I think that this is really only a dependency about how this reflects up into the browser. It might not be a dependency at all. So let's say that we were saying to implement Ript in a browser, you needed to write a bunch of browser code. You couldn't do it just in JavaScript. Then I don't think we have really any dependency on web transport. But if we're saying you can do it mostly in JavaScript with a few extensions, a few additions to the browser, or to a browser that had web codecs and web transport, then obviously that part would be completely dependent on web transport. So I think that this dependency is a little bit vague right now, depending on where we want to be there. But the dependency on Quick and Quick Datagram in particular stuff is I mean, we're very dependent on that.
So, but that means you need some kind of connection mode that is below HTTP, that is directly on top of Quick, right?
I mean, I think our primary mode that we want to work on is on top of H3, on top of Quick. But I realize I'm flailing here a little bit. I think that as we dig into the protocol designs, this would become a lot clearer.
Okay, I have Harold Elverstrand in queue.
Okay. Harold Elverstrand, speaking with my WGC hat on. Do you want to start listing the WGC efforts that you're going to liaise with too?
Yes, Harold, I do, please. Sorry. Can you help send me some text to get the right text in there?
Yep, I would. WebRTC, web codec, and web transport seems like the obvious ones.
I agree.
Pointing out here, of course, that web transport in the W3C doesn't exist, so it might even go in the working group, so that'll be interesting. Jonathan Lennox.
Hello. So two related comments that fortunately cancel each other out, which is to say, given that you're saying, you know, at least there's a bunch of it, P2P should be out of scope, I don't know why ICE is relevant, but fortunately the ICE working group is closed and its work has been folded back into MMusic. So strike ICE, either because we're not using it or because the working group doesn't exist anymore.
Done.
Okay, Victor, are you talking about a general comment, or are we going to move? Is it on this slide?
Specifically on this slide and what Miria remarked before, I am actually not concerned about the dependency. I think it is good that web transport would be developed in parallel with something that actually uses it, because that would allow us to inform design choices in web trans and vice versa. So I view this as less of a risk and more of an advantage of getting both things right.
Okay, so I'm just confirming that the people remaining on the list are trying to make general comments, because we have a bunch of other slides that we want to work through before we get to the general discussion. So I'm going to ask Cullen to move on, and then all those people who have queued, I'll keep you in mind for the general discussion when we get to the end.
Perfect. And just two more
Cullen.
slides here. Okay, so we'll do the general discussion soon, or 3 more slides. Okay. Deliverables, I don't think that these are worth much discussion. We can go over them, but you know, basically we see this as layering into some stuff for sending the media, and I suspect that when I wrote this, I got the H2 wrong here. That's my fault. I think where this probably should say H3 and HTTP. There's separate stuff for starting and stopping the media. It's just the REST calls. There's we need some way of describing what the media type of the media is that you're sending. And we need some stuff that's really around the identity management of what identities can you use, and then which ones are you using when you're calling stuff. When we break the whole thing apart, those are the parts we have. So that's what I've got for deliverables. Dates would be irrelevant if I had them, so no dates. Comments on this slide.
Okay, Mark has comments about deliverables, but they might be general. Go ahead, Mark, quickly, please.
I'm willing to wait if everyone else is.
Okay, let's move on then.
Next slide. Okay, so let's talk about end-to-end crypto here, and what we should say, what we can have, you know, what makes sense. This is what we have in a draft right there, or this is what's in the charter right now today. Let's start there, and who wants to queue on this end-to-end one? I think
okay, let's start. Eric Rascola.
Yes.
Yeah. So no, I don't think this is adequate. You know, and then encryption is like table stakes now, and to have it like explicitly roll out like this is not cool. I think this needs to say that it needs to actually have end-to-end encryption by default, and it has to specify the keying.
Okay, so and would as specify the keying, would you be all right with MLS for specifying the keying, or do you do that as not as?
I'm sorry, you dropped out. Whether it was you or me, I don't know, but I didn't hear it.
Sorry, I got turned away from my mic. My fault. For the keying, if we were going to specify end-to-end keying, are you fine with MLS as the way of doing that?
I don't think we should define that. I tried to decide that today.
that seems like something for the working groups to work out, not something that's chartered.
Okay. And do you feel the same way about HTTP?
I don't know what you mean.
It needs end-to-end.
You lost me, my friend.
Okay. Well, I mean, like the question, you know, we're trying to put in the space here to figure out. So in many of the cases where this is used, the two ends are the same as the hops. They are the client and server here, and the end-to-end doesn't have anything. Okay.
Because it's like a call center or something.
For example, a data center that's, I mean, like half the use cases are basically like a data center is trying to send something to another ASR system, and it's not a multi-party call, it's a simple one. Now, obviously, I think there's use cases too, like a, you know, Hangouts conference or something where there's lots of users that are all trying to share end-to-end media. It makes sense. But you know, the SIP trunking use cases, the other ones are not in that category, obviously, right?
Well, I'm not sure. I'm not sure why you. And that seems like a weird thing to say. Like there's people on the end of the SIP trunking calls, and I want them to have end-to-end encryption.
Sure, but when there is a direct call between the two endpoints that need to process and understand the media, right, with the two people, and it's direct between them, and this is mandates TLS encryption between the two, right? We have end-to-end.
I mean, I don't quite. I mean, it seems like this is really like a like we're getting down into some real fine points here, which is to say, is it a problem to have duplicative encryption in cases where with HTTP endpoints also the call endpoints? But like I'm sure much more like it seems to me that like so I mean, I suppose we could fight about that at some point. But like that would seem to me to be end-to-end. That's at least arguably end-to-end. But I'm trying to avoid a situation where, in the basic case, where like you and I are both connected to the same server and we're both HTTP endpoints on our browsers, like the data isn't clear on the server, which is like what the current design contemplates. So like that's what I'm trying to avoid. And so we can debate about exactly what the meaning of end-to-end means, but that's the thing I'm complaining about.
Sure. So look, I don't have a problem with that at all. I mean, I wanted that in the beginning as well. I agree with you. So I don't have a problem with that. But where we fall down the slippery slope on that is end-to-end encryption is one thing, end-to-end key mechanism is another, and an end-to-end working identity scheme is another, right? And you need all three before you have a workable system. So
I think well, I mean, so I suspect I don't want to. I think we have a lot of people in queue, so like maybe we let's see what other people say. But like I can tell you, I don't find the current testing out the best.
Okay.
Okay, Ronnie.
Excuse me. Actually, no. Propose what text, what you think you would like. That would be really helpful.
Sure, I'll put it in the chat.
Offline, please. Thank you. Ronnie.
Oh, can you hear me? My concern here is about the end-to-end encryption. Is that I miss seeing anything about what is the requirement for end-to-end delay in a call, in a point-to-point call with a directional delay, because that's important for voice and video calling, and more for voice calls. I mean, there are specifications about, and I saw the previous presentation number that has to do with the conference server, like WebEx, but not something that has to do with just a point-to-point call.
Ronnie, I think we had a hard time getting that whole point, getting exactly what we were trying to say. Could you try that one again in text, and somebody can relay it into the room?
Yep.
Can you hear me?
Sorry, Ronnie, we'll have to move on. No one can understand you. Jonathan, Linux.
Yeah, so I was saying, I mean, I was just going to comment that I think the allow for in this wording is awfully vague in the sense that it's like, you know, it could be interpreted as meaning, yeah, if you want to do end-to-end media encryption yourself, knock yourself out, we're not going to help you. I don't think that's what you mean, but the wording here seems to allow that. I think Ecker had some text that he pasted in the Jabber room, which would be more specific, though obviously we can fight about it, but I just feel like at the very least, he said the protocol will define a mechanism for, or something, as opposed to allow for, meaning like if you want to do it out of, you know, the various, like well, the things that are proposed in the browsers where people just put it, you know, do it over the top inside their JavaScript or whatever.
Jonathan Rosenberg.
Yeah, I just want to make sure we're clear that end-to-end encryption is not the same as P2P media, right? We can still have client-server media and have end-to-end encryption. And then besides that, I want to really echo what a lot of other people are saying is a lot of the use cases that people want to solve for are like, we want to make a call to the PSTN, and those are just, there is no end-to-end encryption there. And I want to make sure we don't end up with a protocol that is only usable in environments where it's like a browser to browser inside of the same service, because that's where you can. So that's why for me it's, and then also I really don't want to invent another keying protocol. So to me the goal is that the protocol supports end-to-end encryption, but it uses other protocols to provide the keying out of the band, meaning not in the scope of this protocol. So if you had a group of people who are communicating on a from their browsers, Ecker, like you were saying, they would do something else, get the keys, and then once they've got those keys and agreed upon those keys, outstanding, now they want to place their voice call. Now they use Ript, and Ript has a way for them to indicate, hey, I'm using this key I learned elsewhere. But not do the keying in this protocol. That's what I really do not want to do. Would that wording work for you, Ecker?
Absolutely not. No.
Outstanding. All right.
No. I mean, what I don't want is this protocol be a promise for some future thing. I want it to provide end-to-end encryption by default.
We can't have end-to-end encryption to the PSTN. I don't want to wait for the PSTN to go away.
Yeah, no. But in that case, I want it to be end-to-end encrypted to the PSTN gateway. What I don't want is when both sides are ripped. What I want is to have end-to-end between those two. In any case, I'm happy to debate this offline, but I'm trying to make my position clear.
So Ecker, but to make your position clear, Ecker, your thing is if you want this working group to do the keying protocol for it as well as have encryption.
Well, I want to specify the keying protocol. I want to specify the keying protocol. I'm hoping you can just point at one.
Which one would
point of order here. Let's see if we can drain the queue here. Where I think we understand where people's positions are, and we're not going to resolve that here. But I'd like to hear what other people have to say. Victor.
There are many layers to this protocol. There is the media transport, and above this there is like negotiation, and above that there is a whole SIP replacement enchilada. And I would like to emphasize that a lot of use cases for transferring media over HTTP into cloud are completely not related to telephony. And you can imagine things like, I have a live stream and I'm trying to send it to a cloud live transcription service. And in those cases, end-to-end encryption doesn't make any sense at all. And I want to make sure that we understand that those are cases. So for at least the media transport layer, I want to make sure that it works for cases where the server is the endpoint and the client is other endpoint.
Okay, thanks, Victor. Justin?
Yeah, I mean, since this is a hop-by-hop protocol, like, it's not totally clear to me what end-to-end encryption for this protocol would even mean. I do think that it should be possible to have like a key identifier from MLS and be able to sort of plug that in and basically support end-to-end encryption in a full conferencing system where the keys are never exposed to JavaScript. Like, that seems like a pretty specific requirement that I think we probably could get behind. But the idea that we're already going to send this data over TLS, and now we need to have an additional sort of encryption wrapper, it's not clear what that's actually buying.
Richard Barnes, last comment on this slide.
Oh, that was opportune. What advises you, Justin, is when you have multiple of these hops chained together, it protects the media on the intermediate servers. I was originally in Q to kind of plus one Ecker to having a requirement here that B2B be on by default. To Justin's point about being primarily hop by hop, I think the way that would materialize would be to have like the slots where you would overlay something. So if we're going to have something like DTLS SRTP, you need your media thing to be able to carry the things that you would use to negotiate keys. If we're going to do something like shove MLS into session negotiation, you would need the slots in the session negotiation thing to carry that stuff. I think an implication of having it by default to sorry, Jonathan, but an implication of that is that we will need to point to some we will need to include a pointer to some key negotiation protocol. But I've been chatting in the background with Ecker, and I think I'm convinced at this point there's enough options here that we should be able to just point to something that will be able to work. Finally, to Colin's point about the various layers here, end-to-end encryption versus the key negotiation versus identity. I think if we can get to the point of at least solving the first of those two, I think those are doable and valuable, and identity can come later, much like it has in WebRTC.
Colin, next slide, please. Take us through it.
I don't even know where to start on this one. Okay, so basically, WebRTC provides a lot of provides obviously peer-to-peer media, and there's a fair amount of work to do that in providing using ICE and those types of issues. The initial idea of a bunch of the proponents in this working group was, let's not do that. That was a lot of complexity. Let's just start with something simple. And in fact, whatever the protocol, the Ript protocol is probably runnable over a data channel, WebRTC data channel that could set up for the peer-to-peer thing. So that is certainly the current thinking is the simplifications of that drives it to let's just make this purely client server. That solves us with a lot of use cases, and where the use cases where that doesn't work fall back to WebRTC. So that is the current way the charter I think is phrased, but this this has been raised as an open issue of that. Well, it would be nice to have peer-to-peer media as well. So let me just leave it there and let people who want to comment on this talk about it.
Okay, I think we have Harold in queue.
Surprise, Harold Anderson. For once, I heartily agree with Kellen and have a couple of points to add to the to the bonfire of not doing P2P. One is that a lot of the security models that make HTTP such attractive nuisance depend on the idea of server identity. P2P doesn't have server identity. It hardly has identity. And so I think leaving this out of scope makes the thing much clearer. We should even say explicitly that we're only deploying this in a client-server model.
Thanks, Harold. Eric Rascola.
Yeah, I fear I'm going to be the hater again here, but no, I don't really think I'm on board with this either. It's a little odd, in fact, that at the same time as people are having substantial trouble with centralized conferencing systems falling over due to excessive load, that we're proposing having everything be centralized. I mean, what I'm trying to avoid here, and the same reason, frankly, that I have a concern about the end-to-end thing, is having a bifurcated system where, like, some sets of functionality available in some cases and some sets of functionality available in others, and that, like, and so having this part of the system only being client to server basically means that now, like, you're stuck with like WebRTC and NIST, and you have to maintain them both in parallel, and that creates a lot of bad problems. So no, I'm like not really on board with this. I think they should have facilities for peer-to-peer media. Also, it's just like, yeah, I'll stop there.
Okay, Ted Hardy.
Hardy, peer-to-peer enthusiast. I actually got in queue and didn't queue minus fast enough when I wanted to +1 Ecker. I agree with everything you said.
Then we'll move on to Colin.
Hi, I think I was basically going to also +1 Ecker. At the very least, if we don't do peer-to-peer media here, we want to have a packetization which is similar enough that as a future extension, we'll be able to add it or trivially gateway to it. Because I can see we're going to want it eventually.
Okay. Next in queue is Harold again.
Yeah, I remember the other part of the point was the motivation slides for this all talk about deployments in the data center. Every single one of these arguments is null and void for P2P. I'm very much in favor of reusable components that can be used both on P2P and in this protocol. But this particular proposal is client server and should admit to it and be allowed to do it.
Okay. Justin Bertie.
Yeah, I think that we can look at peer-to-peer media once the protocol is more well developed, because with peer-to-peer, we have the sort of issue of you have a deployed base, and you can only interact with things that also support the same protocol that are out in the field. With client to server, you can upgrade the client and server a lot of times both yourself, and you can move a little bit faster. So I think we probably start with client to server, rely on WebRTC for client to client for the time being, and then eventually support Ript over, say, ICE as a mechanism to bring the same protocol to peer-to-peer.
Okay, I think we have Bernard, and then the queue is done.
Yeah, so just a point, as Harold said, we've really been talking a lot about HTTP here, and in the web transport kind of terminology, that's what we call the HTTP transport. And so if you're looking at datagrams, they would be HTTP3 datagrams. Whereas if you're looking at peer-to-peer, you probably don't want to do HTTP3 on a peer-to-peer manner. So you're talking about what we call quick transport, which is just the raw quick, and then you're talking about quick datagrams. So these are kind of very different things. And this presentation has, I think, mostly been about kind of client-server HTTP3, in which case that's really not a peer-to-peer environment. But some of the media stuff, if you define RTP over datagrams, right, it works for HTTP datagrams or for the quick datagrams.
Okay, I think we're going to try to field some questions now about the charter more broadly, but we don't have a whole lot of time. So if there's anything people have, I did have a list of people further up in the chat there. I believe that included Mark Nottingham and Spencer Dawkins and Watson. Please be brief. We would like to ask a couple of questions before we leave. So let's go with M. Knott.
So listening to this discussion, I'm leaving it with the sense that, I understand why they're using HTTP, but, and while on the control side, on the session control side, that makes sense. For the media stuff, I'm really not sure that falling back is going to give you the properties you want. And I don't think it's going to be always reliable to fall back. I think it's going to fail in really interesting ways in certain deployments. And so I think the charter needs some wiggle room in the deliverables so that we can have a discussion about what the desired fallback scenarios are and whether it's better to fail hard if you can establish, for example, a quick web transport connection rather than trying to fall back to the HTTP previous version ladder. And I know that a lot of focus has been put on let's reuse the HTTP, but I think there's a little more thought and a little more discussion before we use it for the media part of things.
Okay, Watson, if your current comments are still current.
Yes. So on the Jabber, there's been some discussion about a gap between the semantics of HTTP, which make those things like the stateless load balancers, et cetera, and the auto scaling work, and the demands of connecting two clients to the same server so they can have a telephone conversation between them. It seems to me like some of the inherent properties of each system are in conflict.
Spencer.
If I was going to try to make a short comment about this, it seems like to me that what's being proposed in the current charter is kind of like a slam dunk to see how well stuff works, and that could be fine. You might want to make a list of the things that you are depending on that aren't quite there yet, like web transport and quick datagrams and things like that, if this is supposed to be a short-term kind of deliverable. because I had some concerns about that. And the other thing that's probably worth me saying is I'm really hoping that you all find out things about media over quick, whatever that means, that we can use in lots of other places. So I would hope, that, I was thinking to the point of, does that even need to be in the same working group as the rest of the stuff? Maybe it does, but I would hope you'd be thinking about the general case of media over quick, so that we're not doing another one in a year or two, because this one wouldn't work out. Thank you.
Okay, Mo.
We can table mine. I'll take the list.
So Jonathan and then Magnus. So Jonathan.
Yeah, I'll just be quick. I want to make sure we don't let massive scope be the enemy of a well-defined scope we can actually solve for in reference to the P2P problem. We've got a ton of use cases that are client server, which is the motivation for this work. The motivation for this work is a bunch of people who are really struggling to get media processing done in the cloud. And I would hate to basically make a protocol that solves for a use case that we already have a good solution for called WebRTC, and then prevents us from actually getting a good solution for the thing we actually want to solve. So I don't mind eventually solving it, but I want to punt it down the road and not get ourselves swamped up in the mass complexity of and all the dragging of P2P problems that are going to come with it if we try and knock that in the first phase. So I'm in favor of deferring it.
And finally, Magnus. Oh no, Magnus, no audio. Where's the mute button?
Here. Sorry. You hear me now, I assume. So my concern here is about, I think we need to cut these things up a bit. And I think the media transport part is something which you can actually separate from the signaling stuff and still have maybe some of these state sharing, etc. working, but it needs to be looked at, because I think the media over quick or H3 is going to be something that's going to be reused in a lot of different settings, and it can't be tightly coupled. The other aspect of this, I think, is to not repeat the RTP's mistake and not be clear on the media model and how you handle, even if it's not in scope immediately, the multi-party questions, they're going to come in here. They're definitely going to come in at some point, and you're going to need to handle them, and you need a model for it. Otherwise, you're going to miss things which are important from the starting point. Thank you.
Okay, that's the discussion over. Mo has some questions for people. I don't know that we're going to say yes, this is a working group at this point, but we do have some questions.
Yeah, so there's clearly a lot of energy behind doing some work here, but there's also clearly a lot of questions about scope, questions about dependencies, ambiguity about the fallback scenarios and how important those are. So it's definitely premature to try to resolve all the charter issues. We won't try to do that in form today, but we would like to understand if there's a substantial amount of energy that people are willing to put towards getting these problems solved, and we'd like to hear any objections from anyone that thinks that there are already solutions and that the problems are not well defined. Very brief. Maybe try to keep it 15 minutes, please.
Maybe what's worked in other sessions here is people who are willing to contribute effort into pursuing work in this general space and realize that that work will initially be defining the scope more clearly. Please put +1 into the WebEx chat, and we'll tally that up. And then while you're doing that, anyone who is willing, who thinks this is a bad idea generally and has specific reasons why we shouldn't be pursuing something in this area, please join the mic queue. I'll try to filter those out. I see Mark Nottingham. You can speak, Mark, while other people continue to web.
Okay, I just had a question about the next steps. My presumption is that there's going to be a continued discussion about the charter on the mailing list. This is not going to be one of those ones where the IESG goes off and magically drops the charter on our lap, right?
No, this will require more iteration based on the discussion we've had here.
Sounds good, thanks.
Okay, Jared has a question too.
It's more a comment. I think trying to keep the scope for this, I think scope for it narrow enough that it's attainable with the people who are engaged, I think is really going to be key here, because given the areas where we can potentially go with this, I suspect that there's a lot of places where we can accidentally end up in the ditch, even if everybody is well-intentioned. That's just my thoughts.
Okay, thank you. I think we're mostly out of time now. Thanks for everyone who came along. Mo, any last thoughts?
No, let's just keep this charter discussion going on the list. Thank you for your time.
Thank you all.
Thank you all, folks. Bye for now.
I too.